Hello, this is Fat Mamas, and we are here to present our ideal class. Our theme is going to be kernel.
What's the kernel? The kernel is the main component of most computer operating system. It is a bridge between application and the actual data processing done at the hardware level. The kernel's responsibilities include managing the system resources, the communication between hardware and software components. As when we have something running on the operating system, or if we want to run something, the kernel is in charge to see if the CPU can run the application. Then we get some information from the memory and the input and output devices in order to run it properly.
When designing a kernel, we have three main approaches. The first one is the monolithic kernel. In a monolithic kernel, all OS services run along with the main kernel thread, which is also residing in the same memory area. This approach provides rich and powerful hardware access. Some developers, such as the creator of Unix, Cham, maintain that it is easier to implement a monolithic kernel. The second approach is a microkernel. Microkernel is the term describing an operating system designed with the functionality of a system that is moved of the traditional kernel into a set of servers that communicate through a minimal kernel, leaving as little as possible in the system space and as much as possible in user space. A microkernel that is designed for a specific platform or device is only ever going to have what it needs to operate. The microkernel approach consists of defining a simple abstraction over the hardware with a set of primitives or system calls to implement minimal OS services such as memory management, multitasking, and inter-process communication. The third approach of designing a kernel is the hybrid kernel or modular kernel. It's used in most commercial operating systems such as Microsoft Windows, Apple, and XNU. They are similar to microkernels, except they include some additional code in kernel space to increase performance. This kernel represents a compromise that was implemented by some developers before it was demonstrated that pure microkernels can provide high performance. These types of kernels are extensions of microkernels with some properties of monolithic kernels.
I'm going to compare the kernel to real life. We can imagine the kernel as a manager. So the manager is how going to control the processes. So in order to know what are the process doing and the process to know access, to request access, they get these methods named synchronization and communication methods called inter-process communication. Here are some examples of the kernels in the computer operating systems. For example, the Windows NT implements a hybrid kernel. Also, the Mac OS implements a hybrid kernel, while the Linux implements a monolithic one. In mobile devices, Android implements a monolithic one, BlackBerry a microkernel, the iPhone OS implements a hybrid kernel, and the Windows Phone implements a monolithic kernel. Some specific differences between the kernels is that monolithic kernel was developed much before than the microkernel. Microkernel was developed at 1980s. The monolithic are faster than microkernel. At first, there was a huge difference. 50% slower were the microkernel versus the monolithic. Right now, the L4 is just 2 or 4% slower than the monolithic. Usually, monolithic kernels are generally bulky. It means that it needs more space. Monolithic kernel device driver reside in the kernel space, while the microkernel reside in the user space. Microkernels are more secure than the monolithic kernel and used in some military devices. Monolithic kernels use signals and sockets to ensure the IPC, the inter-process communication I just described, while microkernel approach uses messages queues. So, thank you for paying attention, and we are pleased to present our kernel presentation. Have a nice day.